Recording. Okay, we're good. All right. Hello and welcome to the Finetuning Stable Diffusion meeting. Sorry for the delay. We're the SMU AI Club, as you probably already know. If you could please scan this QR code really quick and let me go on slideshow so it shows the whole screen. If you could really quickly scan that so we can get the extra money for our pizza, that would be excellent. So I'll get out of your guys' way. Back. And let me know when you guys are good with that. I'll do that later because I haven't done it yet either.
See, this would be the meeting for the. Remember that QR code you made?
Yeah. You should probably make it.
It's fine. It's not that big of a deal.
No, we need a sexy QR.
Hello.
This would have been the meeting for the sexy QR code.
Yeah.
Like it would have made sense here.
It made sense last time.
It did, yeah. Because that was also a diffusion meeting.
We should do it for every single meeting, right?
Yeah, I think so.
We actually should do.
We had a sexy QR code last time.
Alright, so we're all good.
I thought it was really cool.
Right.
I thought it was sick.
But too bad we have this.
Yeah, it's really lame. I'm sorry, guys. I didn't diffuse it. All right. So also here's our Discord and our YouTube. We're gonna be putting these slides in the Discord channel later. So if you're not on the Discord, please join that. And there's our YouTube channel. It will be on the slides later if you are on the Discord.
We post recordings to YouTube.
Yeah. All right. Really quickly, briefly, the rest of the semester, how it's going to go. So today we're doing the Stable Diffusion meeting. Then in I think next week we're going to be doing the Diffusion, or well, I guess it's going to be the 20th because that will be after spring break. So right after the break, we'll be doing the Diffusion paper reading group.
What paper are we doing?
Yeah. So I'm curious if y'all wanted us to go over paper. Would you rather have it be like some topology or some topology based sheet diffusion, or like a diffusion model, like just going over diffusion models? If y'all heard of Sora, we could go over how that probably.
Yeah, there was a Microsoft released a kind of sort of technical report from Sora.
Oh, cool. All right, yeah.
And it's not it pretty much.
No, I heard that.
It's not bad.
We either let's go over deep or topology and diffusion, or diffusion video generation and how that works. Y'all got any opinions on that? Go over either one.
We can freestyle because really there isn't like an essential diffusion paper.
We can also put a poll in the chat.
Yeah,
if that's the best.
Yeah.
And say here's 4.
Also, we should probably put a poll on the last meeting. Do we want to do? We were either going to do more artificial life stuff like from last semester, like we could find a paper to talk about, or we could do something with self-supervised learning, or something else.
Well, but if anyone's interested in something generally AI related, we could probably do it on that. We've done diffusion, or we've done language models. So if there's something else that is kind of interesting, go ahead and let us know. We may be able to do that.
We'll send out a poll.
All right, so let's get on with the meeting. So quick overview. So I don't know how much you guys are acquainted with Stable Diffusion and what fine tuning or how you might do it, but just a quick overview. Stable Diffusion is basically generating AI art. So you will start with and I'll have a picture of this in a second. But you start with a noisy, just Gaussian, however many pixels, 512 by 512, 1024 by 1024. You start with that many pixels, and you want to diffuse those pixels into an image that looks like something that you want. So you base it on your conditioning. So you'll give it a prompt, and it'll say, okay, give me a picture of a cat. And it will generate, we'll take this noise, and it will generate a picture of a cat from that, right? So that's what Stable Diffusion is. But how are we able to fine tune it? And what that means is, can we add our own, individual? Could I add myself into Stable Diffusion? Could I make a style that shows up in here in the Stable Diffusion output, and I make that Stable Diffusion go into that style? Are these things possible? And it turns out there's many ways to do this, and let me say it is possible, and there are many ways to do this. So here are a couple things that people usually do. People do textual inversions, which is when it was first starting to become popular to want to train Stable Diffusion, people would go to textual inversions because Stable Diffusion, actually fine-tuning it, would take hundreds of really good GPUs, and the regular individual doesn't have access to hundreds of GPUs to fine-tune actual Stable Diffusion on. So people find these shortcuts and these tricks to get around these things. one of which is textual inversions, which is basically in the embedding space where you're conditioning. You're basically going to find close embeddings to a new thing that you're trying to generate. So let's say I have like a cat and a dog, and I wanted to generate, a fox, right? You can think of that as kind of a combination of cat and dog, or kind of related to the two. So you could generate, or you can make fox, based on those two embeddings. And then thus you get a textual inversion that you can tell your prompt to say, or you can go into your prompt and say, okay, I want a fox in my image. And it will say, okay, here are the embeddings I think are related to it, and here you go. So that's how we'll embed those things. Dream Booth fine-tunes the actual full unit in the Stable Diffusion model. So I'll look at I'll just actually go to it right now, just to show you what's going on. So the textual inversion is happening. So in the conditioning, you're going to the embedding space, or when you put into the embedding space, you're going the text that you're moving into the embedding space is going to be altered with that textual inversion method I was talking about. But then for the Dream Booth method, you're actually going to be fine tuning this full unit. So you can imagine that could get very costly. So a lot of people couldn't even run Dream Booth when it was like very, very popularly used, because it still was a lot of, you need a lot of RAM to load everything in and actually train it. So people also didn't love that method. So people came up with LoRa. Or there was a good paper. I don't know when LoRa came out. 2021, yeah. And it actually directly alters the cross-attention layers in the network. So you can see those QKVs, those are the cross-attention layers. And you're basically going to make some matrix and multiply or do whatever to these matrices to give you, or to sway Stable Diffusion to go in a certain direction, right? And finally, and take this with a grain of salt, but I've been seeing a lot of people using the Face ID plus V2 IP adapter. So IP adapters used to be really popular, like with textual inversions. It was IP adapters and textual inversions that were really popular, and they kind of sucked. And suddenly, like a month ago, I started seeing these pop up all over again. People would use them, so you can basically give like an IP adapter like one image of a person, and it can like really well generate more of you based on that one image, which we'll see that LoRa and Dream Booth, they require like 20, 30 images, even more sometimes. And basically what IP adapters allow you to do is prompt Stable Diffusion with an image and do it really well and reliably. Well, when I say that, it used to be really bad. They kind of suck, and I'm surprised that I'm seeing them again. But those are kind of the four different methods that people generally use. I'd say that LoRa is the most common one, and we're going to be looking at that. Dream Booth is probably the second most common, and then textual versions. I'm telling you, I don't see IP adapters a lot. But yeah. So which to use, and it depends on your setup. So like I said, it really depends on how much GPU and RAM you have. To put in perspective, this machine, and I did local training on this machine has 8 gigs RAM, and it's a 3080. And it trained with one epic, and I think so. I'll explain what these things mean, but I was doing repeats of 10 and then epics, and one epic, so that's 200 images that I was training with. I'll explain in a second or a little later. But it was able to train that in about 8 minutes. So it still takes a little while, but it's not like, taking several days on my machine, which is nice that you can actually train these things. And yeah, okay, I think I explained enough here.
I'm curious about how like Stable Diffusion works. We have a recording of what we did last semester, and we'll probably go over it again this semester as well next meeting.
Yeah, if you guys have any questions about these types of things, or you're like reading a paper, you have questions about it, feel free to just ask us in the chat. We're like always, trust me, one of us is gonna answer like immediately. So yeah, just feel free. Yeah, like, where's your paper?
Software or hardware?
This is the model architecture for Stable Diffusion. So like the way the weights are like constructed, so like you send in an image, or you send in noise and it gives you an image. How do you do that? And like you could just throw weights at something, but you got to do it more strategically than that. So that's what's being shown here. And this is Stable Diffusion. But yeah.
Does it come in from the conditioning and pixel space?
So the pixel space is to put it into just a quick overview. You basically have an image and you compress it into an image of pixel space you can compress it using an encoder. So there's something called a variation autoencoder. You compress it and it can uncompress it. Leave it at that so you compress an image. And that's what's called a latent space, the compressed area that the compressed image is in. And you basically add noise to that. So you can think of, I have a picture of a cat and I can add noise to it, and you train the model to remove the noise from it. So you can then give it noise, and then it'll unnoise the noise to give you a mix. And the conditioning is, I can give it text, and it learns to associate the text with how to unnoise it. So I can give it text.
Unnoises the noise.
Yeah.
You know, there is no nothing behind it.
The noise is like Gauss, like you sample from a Gaussian, that would be the noise. So you basically like add Gaussian noise. You basically, what's the word I'm looking for? You destroy the image and you teach the model to
Reconstruct.
Yeah. There we go.
Is the latent space lossy?
Not really.
You say latent space, like, I mean,
It's
is something like,
so basically it's like they
when you say
they-
compression, I think.
train an autoencoder, and they basically throw everything at that autoencoder. It's kind of
not
fun.
that lossy. It's like very.
Okay, but it's not like principal.
It's a really
Yeah,
nice.
no,
It's like it's very crazy.
Do you know like what a variational autoencoder is? Okay, so basically the idea is you can so an autoencoder is just like a network that it's like an encoder or decoder. So it encodes to some latent space and then it decodes out. The problem with a normal autoencoder is your latent space is going to be really bad, right? If you're just training for reconstruction, it's not going to be very good. So the variational autoencoder uses some stuff from variational inference. It basically adds a penalty term for your latent space diverging too much from some distribution. And usually the distribution you use is a normal distribution. Because why not, right?
But the encoding process is lost.
It's lossy, but it's not like
It's-
if you encode it and decode it, you will basically not be able
It's
to
somewhat lossy, but it's still pretty good.
like you wouldn't be able to tell if you encoded it.
Yeah.
If you encoded it, you would be like, oh yeah, it's the same.
Like if you train it well, it'll still be pretty good. There is there's always going to be some amount of loss, but it's not like a traditional image. It's not like an image compression algorithm where it's like extremely lossy.
Yeah, like PCA is like
Yeah.
like you throw it at PCA and invert that, you get something completely like it looks very different. This you give it the input.
Because it's like a neural network, so it's a lot more expressive than
Anyways,
PCA.
if
but
y'all are curious, we went over this
Yeah.
like last semester. We'll probably go over it again more in detail in the next meeting because this is more like general. But if you're curious, we can also talk after.
But they do diffusion in the lead space, and it before people were doing pixel space, and this worked a lot better. Yeah, that's it.
All right. Any more questions? Are we good to move on? All right. So really quickly before we go to actually looking at the different methods of not methods but different repos that people use for these things. There's one called Kohya, and they have 4 different types of scripts. So there's like a Kohya /SD scripts, and then people basically just use those and kind of do different things with them. And they have 4 different main ones that people use. There's the Kohya trainer, which is basically it's just straight up training the whole model from fine tuning the whole model, which you can imagine takes a lot of GPU power. And then they have Kohya Dream Booth, which is just using like the Dream Booth method that we talked about earlier, which you can also imagine might take a lot of power, but it also you don't have to give it that many images to actually perform the fine tuning. The Kohya LoRa fine tuning is just for general LoRa fine tuning, and it actually updates the pre-trained model. So you basically you're gonna inject the LoRa during the training, and then you output the whole fine-tuned models. That's usually like a couple gigs, right? So each model, like Stable Diffusion model, is going to be a couple gigs large. But then our last method, so the Kohya Dream Booth method, or LoRa Dream Booth, it's the same as not the same, but you can train like these like a person, an object, a style, like we were talking about earlier, on a small set of images, just like the Dream Booth method or the regular Dream Booth method. And instead of injecting the weights during the training and then outputting the full model, you only get you output the LoRa weights, and then during the inference, so when you're actually asking for an image, so you generate an image, then it will inject those LoRa weights into your Stable Diffusion and do it when you generate, instead of having the model and the LoRa combined when you generate. You have them separated, and then you can combine them when you do the generation. So that gives you a lot of added benefits, like you can compound LoRa's in different ways or weight them differently. So it's just a very powerful method for fine tuning and getting kind of different styles and different people, or maybe a picture of yourself without having to actually change what the model is doing itself. So you're still working with the same model. You're just adding this LoRa. You're changing some stuff during the generation.
We talked about this with LLMs, I think, but
Yeah.
LoRa, you can, because it's really nice. You can just kind of add and scale things really easily. Like, it's super simple. So that's all Trevor's talking about.
All right. So that's going to be like the conclusion of the slide deck. And we're going to go to look at some Colabs scripts that you guys can run right now and actually train on. And when I say right now, I mean probably not right now, because Hugging Face is down for some reason. So when Hugging Face is back up, then you can use them, and it should be good.
Right now,
I have no clue what's going on right now, and they're usually not down for like hours on end. So that sucks, and yeah. But you can also do a local download, and I was going to train with the Colab scripts earlier, and then they crashed, and then Hugging Face went down, so then I had to train locally. So I'll show you how I did that as well. But I'll just show you. So I have a Colab script all like finished out. You can see, and there's. I'll just show you. I'll show you. But yeah, first let's go through the different repos that are commonly used. And I also, just to let you know, I put all the links to these repos in the links section on the slide. So if you want anything that I used for this, they're all here. And okay, yeah. So these ones are going to be like the ones you can download locally, and then there's some Colabs. But I'll go through everything. All right. So if you don't know what this is just, and let me see, is my thing still up? Oh, it is. You see, I told you it only generates cats. So automatic 1111 is, I would say it's the state of the art kind of, local generate, like image generation, stable diffusion thing. It's what a lot of people use. There's two that people use. It's automatic 1111, and then
wait, can you go back to that repo? I just thought it was really funny. They have unstable in one of the tags.
Wait, where?
Right.
Oh yeah.
That's really funny.
Oh yeah, I'm gonna send them. I can send it right now. Actually, let me just do that really quick. Where is it? Share, and link. Go over here. Announcements, or I guess I should just put it in chat. I'll just put it in chat.
We have resources.
Well, I'll put it in resources. Yeah. So that should be like everything you might need for like links wise. But just to go through everything. So this is automatic 1111, and this is when you can clone it onto your machine. There's a lot of setup. So if you're doing the setup and you have questions about the setup, I've had to set this thing up multiple times, and every time it's annoying. Especially if you're trying to get your GPU accelerated for stuff. So if you have to like get cuDNN and all the CUDA stuff, it can be really annoying. So if you have any questions about that, let us know in the chat. But this is basically what it looks like. And just to quickly explain what's going on here, this thing on the top is my prompts, and this thing down here is the, and I was using the wrong model. That's probably why it generated a cat. Whatever. So anyway, this is the prompt on the top, and then the negative prompt is like what you want to go away from. So the prompt is like where you want your stable diffusion to go, and then negative is where you want it to like go away from. So often you'll do like bad anatomy in the negative prompt, or you'd be like ugly or blurry in the negative prompt, and then it will like not do those things, and you can weight it higher. So like if I said a cat and then I weight that really highly at 1.5, let's see what I don't know what it's gonna do, and hopefully it's still running. Please still be running. Oh yes, and this is all running locally on my machine. As you can see, it's kind of slow, and please tell me you're running. Thank you, it's running. And oh, okay, never mind, he crashed. He's mad at me. But anyway, I'll get that running. Actually, why don't I just really quickly start this guy again so that later on it's not a problem when I need him again. All right. But yeah, take my word for it. It would probably show a cat. And then there's some couple other things you can change here. So you can change like the size and the width and height of the image, the sampling method. So that's like when you're doing the backwards, or you're going from your noisy image to your actual generated image. You take steps to get there, and that's what this is like. How are the steps taken essentially? And then we see LoRa that you can apply, and this is the LoRa I made earlier. Then textual inversion and connection errored out. Thank you. I didn't need to know that. Okay, I get it. But anyway, if you want to download this or if you want to clone this, it's all on the automatic 1111 page. And just like the way to do it is not really, he doesn't explain it really well, but he has there's a Windows and a Linux installation. If you're kind of a new time user, I definitely recommend doing the Windows installation because it's really easy to get running. But if you're kind of like, you've seen this stuff before, you're kind of seasoned with it, I would try to use WSL2 if you're using Windows, or just use a Linux box, which would be probably a lot nicer. Unfortunately, I do not have that luxury, but I did use WSL2, so that's a big win for me, I guess. I don't know. So yeah, but he has those resources on there. And then on Stable Diffusion, and I really wish I was running it now. Let's see, is he coming back? Okay, he's coming back in a second. But on stable, on like the automatic 1111, there's extensions you can get. So there's like control net extensions. I'm not going to really explain what that means, but there's different extensions that you can download into it and then use those extensions in your generation. And one of them is the Dream Booth extension, and that's just inside of automatic 11, like the 1111, the web UI. There's a thing up here that says Dream Booth. And let's see if I can, and then I can click it. Okay, it's not even running yet. It lets me click it. I love you, Gradio. Very cool. But you can see, you can, create a model, and you can give it different concepts. So it's like things it should know about. And you can change its parameters. And I know it says error, but you can change like the optimizer and a lot of stuff. And we'll get to that in a second when we talk about training the LoRa and the kind of different things you can change about it. But yeah, Dream Boothing, you can actually do directly in automatic 1111. That's how I've done it in the past. It's really easy to pick up, and the guy who did this has like pretty good documentation to explain how to get it downloaded, and if you're having problems, and then here's some good videos on stuff if you want to do Dream Boothing. And I also put this in. I put all these links in the slides again. And then so those are the two for automatic 1111, and then Kohya SS. So moving on to what I think is the best. For LoRa training and these types of things, and also you can also do Dream Booth. You can do like basically anything in Kohya. It's really, really nice. I've been seeing people using OneTrainer a lot, and I'll get into that as well later. And I did a local install just to show you guys what it looks like, because there's not a lot of good documentation. If you really know what's going on, you could go to OneTrainer, especially because the VRAM usage is way lower in OneTrainer than it is for Kohya. So in that regard, people like it, but it's a lot harder to pick up because there's not as good documentation, and there's basically no YouTube videos out there about it. So you might have to do a little bit of like figuring out to get it working. Yeah, question?
Well, which channel did you post the slide
Oh,
on?
I put the
Resources.
It's in resources. You're in the Discord?
Yes, but I don't see resources. I only see announcements and welcome.
Maybe our like stuff is
Click
set
on the
incorrectly.
information section.
It might be like that we gave the access incorrect.
Like sometimes if you click on it, it'll pull up other channels.
Yeah, I mean that's the only channel I have on the
That's really good.
Can you see it now?
Which one do you have access to?
Yeah, I'll see it.
Oh, announcement and the welcome rules.
I wonder why.
I could
so weird.
I could for now I could put it in the chat, just like regular chat.
Okay.
And then we could figure out. Yeah, sorry about that. We'll figure out why that's happening. I have no clue.
It was working before.
Some stupid Discord crap, probably. Who knows? They're like, oh, no permissions for you.
Discord moment.
Well, yeah, we'll figure it out. But it should be. Oh, can you see the link I put in chat? All right.
First, we can't say retard on this. What is the world?
They're banning us from everything. It's crazy. But anyway, Kohya SS. So this is what I was talking about earlier. And these are actually all based on the SD script. So this is like the original thing that these are all based on. And it's just basically a ton of scripts that do all this training. The reason why you can actually install these scripts into automatic 1111, but generally people use the just use them like in a different web UI. And people, well, personally, I think that the Kohya SS is the best one. It's really good for this type of thing. But the scripts is actually like what it is, what it's running, and so you can see it does like the Dream Booth training, the LoRa training. It has, you can even do textual inversion. You can do like literally all the fine tuning you could ever want with this thing. So yeah, and again, there's installation instructions, and I'll show you guys in a second how it looks like. But yeah, Kohya SS, here's the repo for it, and they also have really good documentation, and they also have a collab, and we're going to look at the collab in a second. We'll look at multiple collabs, and then finally, this guy, he basically made more collabs for each like individual thing. So there's a collab for the LoRa training with the Dream Booth method, the 4 that I talked about earlier. I have no clue what this thing here is. Sure, I mean, customizable SD web UI, I guess. So I don't know. The other 4 are really good, and that's what I have running up here. But this is basically if you want to train, or if you want to fine tune on a collab, so you don't want to use your own GPU or CPU, then you should use these collabs. But if you can train locally, you have the opportunity of the choice to just straight up clone this repo and run it locally. And if you want to see quickly what that looks like, this is the LoRa or the Kohya SS like actual what it looks like when you run it locally. So this is the Gradio, and you can see there's some stuff about, you can change the parameters. I'll talk about that in a little bit too, and then you can change the data set. So you can see that's my instance. You can change a lot of different things about it, and I'll get to that later. But let's just jump into the collabs. So just to show you what they look like, I'm not going to go through the first 3 collabs, but I'm going to go through the Dream Booth, the LoRa Dream Booth one, the one that I think is probably the best if you're going to train one of these. I'm going to go through that, and since I didn't get to run the whole thing because Hugging Face was just suddenly down, I'll show you a completed script that I have that shows you kind of what the outputs are going to look like, and I'll explain how to go through it. So these 3, they all look very similar, as you can see, but they all do slightly different things. So just make sure you choose the right one when you're like, if you want to just do Stable Diffusion training, which you probably don't, but if you want to do it, then make sure you just click the right one, because they're all going to look very similar in terms of like what the content. And actually, let me make this a little bigger for you guys. But they're all going to look very similar in terms of content, but they do slightly different things depending on what it is. So yeah. So let's go through the LoRa Dream Booth. So this is what you can use for training on Colab, and I put the links. I don't use it here. So just to quickly go through here, and not quickly. This is like the main thing, so I'll go through. But basically, what you'll do is you install the dependencies. So this is basically just them installing the repo that we saw earlier, like the SD scripts, into the Colab to get everything running. You can install Xformers in newer versions of this script. So this is kind of an older version of the script, or the notebook. They don't have this. You can't even do this because it will just install the Xformers for you and do it. So you can just ignore that. The Mount Drive is going to put everything into your Google Drive. So it will actually connect to your Google Drive, and you can put your images into your Google Drive, and I'll show you what that looks like. So like, for example, this is when I was doing it earlier. You can put stuff into your train data. So that's where you put your images you want to train on. Well, not train on, but you want to fine tune with. And then reg data is essentially, and we'll talk about this more a little bit later, but this is essentially like counterbalance images. So like, if I had all my, and let me actually just go to my images and show you what they kind of look like. So here's one of my images of my dog, my stuffed animal dog. So basically what you would do is you would give, you would put those images, and I only use 20. Like, it will work with 20. Usually it's 15 to 35, and it will work fine. But you can basically just put all 20 of those images in the train data, and then in the reg data, you'll put images of like other stuffed animals that are not your stuffed animal dog. So if you have like, let's say you had a Dalmatian, right? And your Dalmatian's name was like, I don't know, something, Jasper. Let's say your Dalmatian's name is Jasper. So you basically what you can do is you'll put all your Dalmatian, the pictures of your Dalmatian in the train data, and then everything else, like you can get a ton of other Dalmatians or just dogs in general, and then you put that in the regularization data. Just regularizes where your LoRa is going, so it doesn't like just shoot off to crazy. So it's nice to have, but you don't actually need it, and your thing will actually still work fine if you don't have the regularization images. Yeah. So yeah, this is just the
Really quick question, but let's say you train your new fine-tuned this model, and now let's say you generate some image that you don't really like, and you feed that into regular data.
I mean, you can put it in the regularization data for sure. The thing about that is that you'd have to retrain the LoRa. So if you get like an image that you don't really like, you generally just like tweak a couple things like in the prompt settings. So like what you would commonly do, and this is so you'll commonly do is you'll just like kind of tweak the negative prompt. Like if you're doing a generation session and you want to get like a specific image, there's a couple methods that people use, and they're generally just like you can just wait around the positive and the negative prompt and make it a little bigger. You just like wait around the positive and negative prompt, make things like or add something like it. Let's say you got a picture and then one of the legs was like absolutely just destroyed. You could say like four legs in the prompt, and then weight it really highly. Type in like 4 legs. Yeah, I don't know. And then you would say in the negative prompt like amputee, and then like weight it really highly. But yeah, you can do that, and that will work. And then you can also change the sampling methods, the sampling steps, and then other things about it to kind of give you the results that you're looking for. There's also other things that people use like ControlNet. And really quickly, just to say what that is, ControlNet allows you to like get certain poses and certain styles and just certain types of images based on things you can give it. So, for example, I have something called Open Pose as editor over here. You can basically give like an image of like a open pose person, and then feed that into the ControlNet, and it will say, okay, the conditioning will take it and be like, okay, well, my output image has to follow what this thing looks like, so it will generate a person in that pose.
Is that like a depth to the image?
So it's not. This is not depth to image. This is open pose to embedding. But you can also do. There is depth to embedding as well, actually. So there's a lot of different ones that people use. But this is a really common one that people like. All right, going back to here. So this is just cloning everything. You can see it does a lot of downloading of stuff. Start File Explorer is I actually don't even know what this is, and I haven't used it, so you can just ignore it. But then yeah, so then in section 2, you're going to be doing the pre-trained model selection, and basically what's going on here is you can choose a model to start from. It can be any model, so people will you can generally there's a website called Civet AI. I'm not going to go on there right now because there's a lot of NSFW on there, and I don't want to do that here, obviously. So the ones that are here are good enough. So you can do like anime style. You can do any LoRa is really good because it kind of just like melds to whatever style you want. But you'll choose a model and then it will download the model. And then here's where it is for the custom model. So you can put in, if you have it on Hugging Face, you can put in Hugging Face token. If you have it on Civet AI, you just put the URL here and it will download it. And then the VAE, which is the variational autoencoder that we were talking about earlier, you can download that, and this is just like the regular. They have some examples. It's just the regular, but if you know the VAE like 8400,000 whatever, that's the one that they use there. All right. So data
the stable diffusion.
I might be actually. I have no clue. I could just look and see.
Bro, theirs isn't even a VAE.
Yeah, it is just the regular one.
It's like a VAE with I don't know.
Oh, it is the 84,000.
Yeah, they throw some adversarial losses in there.
Yeah,
they just put everything.
It's something.
Yeah.
They do some stuff. Yeah, it's a VAE. It's a VAE, so it VAEs, So we love that.
Nice latent spaces.
Very nice latent space. Yes. So anyway, moving on to the data acquisition. So just to show you how the data should look, they have some methods for like scraping websites and stuff here, but I'll just show you my. Let me just go to PC. And I'll show you kind of how my images look. I forgot where I put this. And I captioned them too, so I think I might have them. I don't remember where I put them. Actually, I'll just get the. I think there you here, and I'm gonna go. Let's see, is it in? I think I have it in here we go. So this is just the what this is gonna be. Is this gonna be like the image that you saw earlier, and then also like a little caption. And okay, where is it? Hello. Okay, text is having a hard time not opening. Let me close you, and then I don't know. It doesn't want to open right now. Oh. Oh, come on. Oh, let's go. There we go. So you can see it's just like the name of the class. So Howl the dog, and then like he's on a marble counter, and there's like a wall, stipple wall behind him. So I just said like, okay, that's the caption. So yeah.
Oh, so do you just need to manually describe it?
There's many different ways to do it. You can just manually describe it. That's, I mean, easy way to do it. Also, if you want like really accurate, you can manually label it, and you're only gonna have to do like 20 to 35 images anyway. So yeah.
I'm just curious, like when you're naming your image, what are the things that you need to like include in the prompt for it to train?
So generally, you're just gonna include like whatever the image shows. So if I get one like I think like number 4 had a wire in the back. So you see there's like a wire back there. So I said in the caption like there's a wire. I just said wire. So you can't just mention these things. If you literally just said the class label like Howl the dog, it would probably just do like fine anyway. It's just good to give it that context. And there's also other captioning methods that are used. Like people use Blip. If you know what that, I'll show you in a second because it's also on the Colab. But people use many different captioning types of things. I just manually labeled them because it was like 20 images. But yeah. So for the collab that we're going to be working with, it will want it in this type of format. So it'll want the image and then the same same name. So I can't zoom in on that, I guess, but it's going to be like if you have like an image, one JPG there or JPEG, then you'll have a text file that's one.txt, and then they'll just correlate. And then when you put it into the collab, it will figure things out. Same way, just to really quickly go through data acquisition. Since I had the data already, like I didn't need to do any of the data acquisition. But what people commonly do, or what they have here at least, this first thing is just putting it into your Google Drive. So this is what actually makes the drive folder. Like it will make the drive folder for you, and then you just have to go over here and like put it in. So that's what that does. And then there's also stuff to do unzipping your data set. So like let's say you have a giant 4,000 images and you want to unzip them all into a directory. You can just use this here and it will do it all for you. And then you can just tell it to unzip into your drive, and it will just do that because it will have access to your drive. And then you can also use an image scraper. So there's things called Burus, which are just image boards. And you can see Dan-Buru, Joe-Buru, whatever. But they're just image boards with human labeled, labeled, like the labels are from a human and the images are like, so the artist will draw an image, put it on the board, and then people will label the text or label what the image is. So it's really like, it's a kind of like a gold mine for this type of thing for not only scraping images, but also for captioning, like training captioning models. But you can just like, let's say you wanted pictures of like, I don't know, Mario, right? You could literally just like put in here, like so you have to go to Dan-Buru to look at what the labels are going to look like, but they're usually going to be like Mario space, like jumping, and then like that adds part of like that makes sense, gives you the images where it's him and he's jumping, so like that's what this prompt is. And you can see you can do like Ito, Komuru, Toho if you know Toho, stuff like that. And then you can also tell it to go to specific URLs, and there's a lot of stuff you can do here. Again, I didn't need to do it, but this is generally just for scraping images off those websites. And it's very nice and easy if you want to get like one of those characters. For data preprocessing, so this is going to be the captioning and the cleaning and the captioning. This first thing is just for getting rid of any images or anything that's not like an image. So like if you do scrape from like one of those websites, often they'll have like WebMs and GIFs and MP4s everywhere. and you're not going to be training on that. So there's a part here that lets you convert everything into either image or just delete them entirely. You can also add like random colors to backgrounds instead of white. So like a lot of like ref sheets, if you guys have seen those, like character ref sheets, will just have like a white background and a character on front. So they'll colorize the back to make the training more like better, or make it so it's a more resilient. And then the recursive is just for processing subfolders. So that's, if you need that. But here's what I was talking about earlier. So the blip, you can do, they also have waifu diffusion. So this is just for captioning an image. So actually just like, let's say you scraped your images, right? And you have like 3,000 pictures of Mario, but you don't have any of the labels. You didn't get those labels, I guess. You can have blip or just waifu diffusion go through all your images and make labels for them, so you don't have to do any of this manually. And these different things are just about, okay, how do you want to split up the images? So if you have 4,000, you have a batch size of 8. You're gonna split it up into batches, and then you can have different some amount of workers working on those different parts. And it kind of depends how many GPU, CPU, how much resources you have that you can do this. If you're working on if you're working on Colab, this should probably be a really good settings. Like all the base settings here are probably going to be pretty good. I'm just trying to explain like what they're actually doing. And you can do verbose logging. Again, here's the recursive if you want to go through the subfolders. And then it's going to be the same thing for waifu diffusion. It's basically everything's the same with the threshold. And the threshold is just like, is that like how bad can this character look to still be part of your data set, or still be part of not data set, but still be like the same person in the caption. So like it's basically saying how far apart can you be between two people or two of the same character that it's still the same character and you'll label it the same way. So that's what this is. And then custom captioning is just like what we talked about earlier. And if you do custom caption, like which I did, you can give it the extension label. So remember, all of mine were text, so I just did .text, and you give it the custom tags that will just be the dog, the howl of the dog that you'd put there, and then you generally just do --all and process all the subfolders. Even if you don't have subfolders, like why not? And then you can just ignore these two. This is just for adding custom tags. But when you do the training, it should already have that, so you don't necessarily need, well, so you saw in my text files where I have how the dog at the front. If you didn't do that, then you would have to append, but generally you're going to put that there and then do that. So you can. It depends however you make the data set, or however you make the captions, that you'll do that. And yeah.
How the dog is just a unique identifier.
Yeah, exactly. So really quickly to mention that. So he mentioned unique identifiers. If you think about it, when you do Stable Diffusion, it already has like ideas of what certain words are going to mean. Like if you have dog, it already knows what the word dog is, right? So if you made if you made a LoRa and you named it like dog, right? Then you could see there could be some problems there, right? So what people do is, or what commonly you'll do, you'll use something called rare tokens. How the dog is long enough to be a rare token. But there's other ones that people use, and I have a whole list that may or may not load because it's like 114 million lines long. Let's see, is it gonna load? Probably not. But what that is oh, we did. Oh, let's go. It's essentially just a giant list of things that are unique identifiers that you can use. So like the would not be a unique identifier, but ZXQH is a unique identifier. And you could name your LoRa ZXQH, and nobody know what it means, but that's okay because you know what it means, and we love that. And yeah, there's a lot of these. You can see that this list is long, really, really long. How this list is sorted is that the ones at the top are like the least unique of the unique ones, and the bottom ones are like the uniquest of the unique ones. So if you use how it's about how far they are away from the already existing embeddings, right? So you want to get stuff that are really far away from the current stuff that's already in the model. So it's just about, it's like a list of what's further away from what's already existing, right? So I didn't make this list because the script takes like days to run to get all this. But that's what it does. It just finds out what's really far away.
You take all the text and you essentially you take a vector and you maximize the vector's distance from every other element, from every embedded piece of text.
I think so. There was a paper on it a while
In
back.
Clip?
I didn't read the paper, so I like barely know, but probably it's just
Probably, right?
it's the clip embeddings.
Yeah, maximize
Probably the clip embedding space.
All I know is that there was a paper and then they didn't implement it for some reason. So some like other guy on Reddit was like, I implemented the thing and here's my text file, and then I downloaded it. I don't know. And it worked, and he got all like 114 million things, and now I have this. Yeah, it was straight up some like random Reddit person that I downloaded this from. Obviously, I didn't write the script for this, so. But yeah, that was pretty dub. Yeah, it was on. If you're not on r/stable diffusion, you like Stable Diffusion, you should definitely be on r/stable diffusion. It's very, very good, and it's where you get a lot of updates.
There's a lot of dumb people on r/stable diffusion.
There's always a lot of dumb people
on Reddit in general.
Reddit in general, but if you're looking for like,
it's not degenerates.
Yeah, well, usually it will say NSFW if it's not. But
there's a lot of questionable characters.
Yeah, Reddit. I'd say Reddit is like it's a good resource as long as you're like in the right communities, and you
machine
also
learning
like.
Reddits, they used to be really good. They actually used to be a great community, but now it's just hype, and I guess hype is the main thing. But there's just so many people who don't know anything, or just weirdos. Yeah, right. I'm like, bro, why are you on Reddit, dog?
I can say if you're gonna be on Reddit, the two Reddits that I think are like pretty good are r/local llama and then r/stable diffusion. They both kind of like you'll get good information from them usually. That won't just be like horny bait. That's like worth your time. If you really like care about this stuff, you really want to be up to date. The best place to be is on Twitter, like hands down.
Dude, yeah, Twitter. If you guys are interested in ML at all, like Twitter is the place to be.
Yeah. The hardest part is just getting into like the Twitter space. That's the ML Twitter.
You gotta
people.
find like good researchers, but like once you find that, the algorithm will do its thing.
Yeah, you basically just have to like subscribe or follow all the like big researchers, and then whenever you see a post that's like at all not research, you have to like click the 3 dots and say I am not interested in this post. So like it forces your algorithm to like make you only get ML stuff. And then it will be good. So it takes a little while to like make it good for yourself, but once you do, then it's really nice. You get some really cool stuff.
Yeah.
All right.
Variety do you need for your data set? Like yours is just a dog at different angles.
You actually don't really need that much variety. If you want like really good results, you're gonna need like a lot more variety. Like kind of what people usually recommend is like no one image should have the same background. As you can see, I completely like blatantly did not do that in my data set because I was lazy. But you can generally people say, okay, do a different background, like a different location for each image, and you get like 35 of those, and then your output will be really nice.
I thought just if you get a different angle, you get the object from all angles.
That it will be good enough. It will be good enough, but if you really want like the best quality outputs, you'll do different angles and you'll do different backgrounds and different things in the frame, stuff like that. You can get. I mean, nobody really messes around that much. Usually, people just have a different background for each image, and then different angles is the most that people usually do. But
depends on what you want to generate. Like if you wanted to generate like one thing, you just get a data set. Let's take a training something. Like if you wanted to just generate one domain, myself. Yeah, then you just do it on yourself. But if you wanted to have like you can have a lore that's insane that has a ton of diversity, but you would have to even more diversity.
Yeah, for example, there's some lores that are like darkness lore. So you weight it higher and it gives you more darkness in your output image. Like how do you, if you think about how they probably got that, you have to have like all different scales of lighting, so it kind of knows what lighting is and can apply that to the cross attention. So it depends not only on like what you're trying to do, but also on like it depends on what you're trying to do. So if you're doing like an image of yourself, usually it's like you only need like 20 to 35, and you can just do different poses. You could probably do in front of like the same background, but the videos I've seen about that usually say that it's best to do like different. You're wearing different clothing, it's different background, and it's a different pose. It's usually the you could just like do your Instagram. So that would be perfect. Yeah. Or you could just if you could just take pictures of yourself too, in different, like in your house in different angles and different locations in your house, and then wearing different like random clothing. there's a lot of ways to do it, but yeah, there's, like you said, like Instagram, I don't know, wherever you have faces of yourself. All right, so moving on to the training the model. So here's the model config, and basically this V2 and this V parameterization, those two things. The V2 is this a Stable Diffusion 2 model. You should just not train Stable Diffusion 2 models. They kind of suck. And then V parameterization, like this is only used for like Stable Diffusion 2.1. Just don't do it. Don't waste your time. If you do change it, like here, if you do use like the 2.1 models, it should automatically update. At least in the local Kohya scripts, they do. I don't know about on here, but I just don't do too much there. It's kind of bad. And then you give it, so in these sections, you just give it like the project name, so that would just be like How the Dog or whatever. And then these other ones are going to be like where these things are stored on your drive now that you've done all this stuff, right? Or in the content. So when you go through this thing, the safe tensor model will just be stored like in your local file structure on the Colab, but then like your VA and your VA will be there too. But like your output directory, you want it to go to your drive, right? You want the safe tensors to be stored to your drive. So you'll tell it, okay, well, go to that LoRa folder and then save it, and then output the drive is where you can like force it to like, it's not force it, but like if you have an output directory that's in your drive, you want to click that so it knows that it's in your drive, and that will save. It can save there. And then dataset config. So essentially what's going on here is this datasets repeats, and this took me a while to kind of figure out what was going on. But dataset repeats is basically for every epoch in your training, it's how many times one image will repeat, right? So if I have 20 images of the dog, right? And I don't really need to pull it up again, but if I have 20 images of the dog in my images, right? If I had datasets repeat or dataset repeats equals 10, that would mean that each image will repeat 10 times, meaning that my first epoch would be trained on 200 images. The reason why they do this is it's the same reason for that I talked about earlier with like stability and resilience. It's making sure that the model is stable and not just training on 20 images and calling it a day, because that wouldn't be stable. So they'll just repeat the same image over and over again, and it works. And then what you'll often do is also have those regularization images. So you could just combine them all into one epoch, and then you'll just train on all those images at the same time. Activation word is going to be the word that you use for the LoRa. So the person who I got this from just used their parrot. So you can just name it, like I just name it How the Dog. That's what I put there. And then the caption extension is just what are the captions called. I completely said this wrong. So in your captions, it's basically, this is telling it what label in your captions is correspondent to the image, right? So I do How the Dog here and then text, because in my captions I have like How the Dog as like in the caption. So I want to make sure that during training it knows, okay, that one is the one that corresponds to this LoRa. So it won't name the LoRa How the Dog, but it will like make sure the LoRa knows, like when it's training, okay, this is the word that's correlated to the images, right? So I should correlate them so that when he asks for the LoRa, then I know that, oh, this is how I generate this image, or this is where it is, So that's what that is. Resolution is just how big the images are going to be. So 512 by 512 is common for, if you're going to do Stable Diffusion 1.5, it's going to be 512 by 512. If you're doing XL, you're going to do 1024 by 1024. You can actually, I believe you can like change it to be anything. Oh no, you can't. But you can change it to be like other ones that are not necessarily in there. And that, I personally wouldn't do that, but you can do that if you want the LoRa, because it just makes the LoRa bigger. You can just do whatever you want there. Honestly, it shouldn't affect like the training, but it might affect depending on what model you use. So just look at what the resolution of your model, like the model you're training with is, and then just use that resolution is what I'd recommend. Flip augmentation, that's just for augmenting the images. You flip it. And then I actually don't even know what keep tokens is, so we're going to ignore that. And yeah, here you can see is the config for what's going on. And then you can see there's like the dropout rate if you're kind of pointed with these training things, or that's the caption dropout rate. So that's not actual dropout, but like how many of the captions you're going to drop. And then here is where, like, if you're familiar with the LoRa training, this is where you'll probably see a lot of stuff that's very familiar. They also, you can do like Chorus and all these other ones. Yeah, like Loha. I don't even know. Just use LoRa. Like Chorus people, it's so on Civet AI. Like you can upload whatever like models you kind of want. And I do see a lot of like Chorus models. Not like that many anymore, but they used to be popular. But LoRa is just way better. I don't know why people just use LoRa.
They just want to be different.
They just want to be different. Yeah, they want to be quirky on Civet AI. I'm standing out because I did a like Chorus model. Yeah, Key LoRa, even better.
Or what was the new one? Dora. Yeah. Dora.
Hey,
actually a good favorite.
Yeah. Oh, okay. I have to read it.
Yeah, Dora.
Yeah, I should have used Dora for this.
You're not using Dora? Skill issue. You're still using Dora?
Yeah, it's sad.
It's been like 5 days.
Yeah, it's already implemented probably too.
Like 20 times.
Like 2020 is like ancient history.
True.
Dinosaurs.
Yeah.
Didn't even have Sora back then.
You know if these LoRas are convolution LoRas?
We're still using
the
StyleGAN. Losers.
All right, so then here's like the LoRa training stuff. So this conv dim these are not conv. You can do conv ones.
Is it convolution?
So the LoRa base ones are just the text, but then the locon and these two are convolution.
Oh, those are convolution.
Yeah, so you can do convolution.
Oh.
And that's what this is right here. This is the convolution dimension and the convolution alpha. So you can do it, and that's what I should have said.
Have you tried that?
I haven't actually.
Yeah.
So
I'm curious.
we could. I mean, it's not that hard to
What
set
is
up.
it?
It should
It's a LoRa on a convolution instead of LoRa on a FO.
Oh.
Yeah, which is interesting.
I don't know.
You only edit the text.
That is interesting.
Well, you only edit the text with normal LoRa, but I think you also edit the attention with normal LoRa.
No, you do. Like the projection makes stays there, right? Yeah.
So you can do convolutional or just regular LoRa. I just do regular LoRa. And then you can set the network dim and the network alpha. Generally, I set this to be 128 and 1. Usually, you're going to want to set your network dimension to be 128 or higher, depending on how much RAM you have. Like on my GPU, I just did 128 flat. Fine.
So there are LoRa's on the convolutions in the UNet? That's basically
Yeah.
Okay.
So, yeah, you can do that. They say when in doubt, just set in the alpha.
That doesn't work as well.
It can work better. It depends.
It can.
Yeah, it's these kind of things are. It's about how long you train, how much RAM you have. It's a lot of different things.
Yeah. More of an art than the science, I guess.
Yeah. You kind of have to. If like what I recommend is just like training a couple LoRa's, kind of do a couple like tweak some things, and then see what one you like the most, and then taking that. Yeah. You can also they allow for like checkpointing and everything, so you just take the first checkpoint and see what it's doing.
Yeah.
But yeah, so network dimension and network alpha, 128. They say
it makes less sense to modify the convolution kernel, in my opinion.
I think it does too.
Modifying the cross attention makes, because that's what the cross attention is supposed to do, right? It's conditioning. So like I don't think it makes, like, intuitively it doesn't make a whole lot of sense to modify.
Well, that's why I say that. That's why people use LoRa the most. Like that's why I see LoRa the most, because not only is it like easy to understand, but then also
it just makes more sense.
Yeah. So then they set these two to be the same, but you don't have to. Like you'll see later in my local install, I just did 128 and 1. The main one is you just want network dimension to be above 128. Alpha you can kind of tweak around and see what you like, but it shouldn't affect things too much. And then optimizer config. If you don't really know about the optimizer, you can just keep all the regular things. But this is just the Atom W8-bit one, because you're doing the LoRa. And then you can change some other things like optimizer args and like the learning rate and the text encoder learning rate. And these are our scheduler. I recommend just leaving it all the same unless you like really know what's going on. There's not really any point to change them unless like you really want specific outputs. You're gonna get something fine if you just use their base. Like they made it so it's gonna be fine. So I just recommend just using all their regular stuff and calling it a day. and then you can see here's the config, and you can save the config if you want to bring it to a different thing. You can do that. And then here's the training config. If you want to make it so it's low RAM, you can do that. Enable sample prompt, no clue. And then DDIM is just the sampler, so you can choose whatever sampler you want. And this is the same thing we saw earlier, so you know how fast or where you're going to be stepping, right? So you can just do whatever sampler. I usually just do DDIM because it's good for this type of thing. Noise offset, if I remember correctly, it's for it's the same thing with the white image background type thing where the background is a plain color and you want to make it more resilient. That's what this noise offset is. So if you change the noise offset, it will make it a little bit more resilient. It doesn't really matter. Just set it to be if you can mess with it, but
is this essentially during training?
Yeah, it's during training.
Yeah, no, I didn't know people use solvers during training. I thought they were only used.
They use it.
I thought you have to train discrete.
They use it during the training. That's what they have here. So I assume you can. Yes.
I feel like that'll be a lot worse.
They use it.
I don't know. What do you? I feel like. Yeah. Right.
Turn down the noise. Apparently it works.
Yeah. Because you can actually. I don't think you can learn a good trajectory until you. I don't know. Maybe I'm wrong. But yeah, maybe it does work.
You're kind of lost sight of what the objective was there for a while.
Oh, sure.
What's the goal here?
So the goal is just it's just about fine tuning and wanting to change the model in a way such that you don't have to actually fine tune the whole Stable Diffusion, right? You can rather fine tune, this small matrix thing that's a lot faster to train and can give you results that you want. So it's mainly about parameter, like you said, parameter efficient fine tuning.
Yeah. So if you don't have access to a ton of
Stable Diffusion UI.
Yep.
What is it's changing to these values here, or what is it trying to optimize?
So in the prompt, I'll type some stuff, right? And then if I give it LoRa, right, like that, the LoRa is, and we talked about this with remember the cross attention layers. The LoRa will actually change. It will adapt the cross attention layers. It will change those, even if you put it in the prompt here. But this is just signaling to the model. It doesn't actually put it in the prompt, the text conditioning. It uses it it changes the cross attention layers during the inference.
Okay, so these additional parameters here it's not playing around with these other.
No, these are completely different.
So you remember the projections in cross attention? So in attention, they also when you do the projections for your query key value. That's basically the parameters. So LoRa gives you a way of you can change a very small percentage of the values because that's the low rank thing, right? And then you can represent, you have your original weights, and then you have these LoRa weights, which are essentially it's a low rank representation. But if you do a multiplication, it's the same size, and then so in inference you can just add them. Basically, that's what
Dr. Larson. W's on those.
Yeah.
Yeah. Those projections. Yeah. In attention. So cross attention, kind of same thing. That's what you're modifying.
So you can directly modify
and
those.
It's way you don't need nearly as much VRAM because the amount of weights you're actually learning is very small. That's why it's nice.
And then
so if you're not meta. You can actually fine tune.
This is what allows you to fine tune models like llama and stuff like that as well. Same exact procedure.
We talked about it, I think, right? Yeah. We have it on the YouTube. I think it's there.
Yeah, once resources come.
Once resources comes back.
Yeah. It's fun.
Okay. Well. Yeah, you'll be able to check that on the YouTube. Yeah. So then, anyways, all the other things here are just how many epics are you going to train for? Well, this is for the sampler, but yeah, they just include some other stuff. So if you know what's going on, I just generally just keep it how it is. Why not? And then you can start your training. So we've gone through all that annoying setup and getting our data set ready and setting all these configurations, which you'll probably just set to be the same as it already is, because it's just probably just good. But then you want to train, so you give it all your where your things are. Well, these should all be the same as before. Like they'll give you some stuff, and then you can just like run with that. I'm pretty sure, because they just have these here. Like you can edit the configs if you want, but generally the samples are going to be good. And then it will perform the training. And basically, all this stuff that you're seeing here is just like, and this is actually the same that I have on when I did my training over here. So you can see like when I did my training with it, basically tells you all your config stuff. So that's all the things we set. And then you can ignore the stupid TensorFlow errors. And then you see it takes my images, and then it will ACS as 200 because that's the 10 times the 20. So I did the repeats of 10, so that was 10 times 20. That's to get 200. I didn't do any regularization images. And then it will again tell me what I'm doing. And then eventually, then you see it's loading in the unit and doing all this stuff. It's loading in everything. And it's doing LoRa's and it's doing all this stuff. And then you can see here's where it's actually training. So it's just telling me, that whole first part is just telling you, like, what are you doing? And then it's saying, oh, okay, I see what you're doing. Let's train for 200 steps. And then it outputs to my directory. And I'll show you that in a second right after I finish this. Yeah, it took 8 minutes, yeah.
So this was on.
So yeah, I would have done it on Google's runtime, but then Hugging Face died. So I wonder if Hugging Face is it still down? Like that's crazy. I don't know.
I saw Clement tweeted, but he said basically apologized.
Yeah, I would have. Wow, I am impacted.
Bro,
so yeah, I wish you guys could have like actually. It'd be nice if you guys could actually like run this alongside, because my plan was to like because I had the training images, I was just gonna give everyone the training images and then we'd all run it. But it actually died at the worst possible time. So I kind of had to change what we're gonna do. No, it was using my GPU, and it took 8 minutes. No. I put everything on my machine.
Over.
Okay.
So it was all on my machine. I just ran everything.
The Colab wouldn't.
Yeah.
The Colab wouldn't work because the Hugging Face is down.
Yeah. Oh, you mean the one locally?
Yeah, it's the same one.
So it's the same output here, yeah, because it uses. Remember, I was talking about those SD scripts. It uses the same script. So that whole thing at the beginning was just like that whole first five sections, just like setting different parameters. And like I can show you what the command actually looks like. And the reason why they need all those parameters is because this thing right here, this whole thing, is the command you run on the script. Like so you need to tell all this crap because it needs to input all these things, right? So if you need to do that, then that's why they ask you for so much like random crap. It's because they need to when they call the script, they need to give it all this information. So that's why it's asking you for so much. And then you can see this is just training. It prepares the accelerator. It's the same thing we just saw. And then here's your training for 28 epics, or not 28 epics, but 28 steps. You can see it's just doing stuff you've seen before. Well, I guess it's 330 steps, but then stuff takes a little while. No, I had it right the first time. Never mind. It's just training. It's training. And you can see like on here it can take, this one took 10 minutes. And this is for the TPU, like a Google TPU. So it's pretty quick. It's nice and quick and easy to get things like running. And then you can visualize the loss graph with this, which is really nice. You can look at the LoRa weights. You don't necessarily have to do any of this. It's just checking if my thing is working well. Generally, you can ignore all this because I'll show you. This is just kind of the end of it. It's like you can upload it to Hugging Face and then upload the data and all this stuff. This is just for like kind of logistic stuff. But once you run this thing here, this is when you actually get the model. And the model is just going to save. If you're running on here, it's going to save into your drive as like a save tensors. But since I was running it on here, it will save into here. And you see that last dot save tensors is the LoRa right there. You can see it's only 147. What is that, like 14 megabytes? It's small. So it's really small. Or I guess it's 147. It's small. So it's nice, and yeah, and you can just like inject that like we were showing you earlier, or I showed you earlier, and that's this whole Colab. There's also a Colab if you want to run the actual like GUI, like the Gradio GUI, and here I'll show you that really quick. This is like, remember, this is the Gradio GUI, and you'll see like when I click parameters, all these things are the same. Like, oh, we have usually the only one that I change is this. Where is the rank dimension is the only one I changed to 128 because it's at 1, and obviously you don't want it to be 1. Generally, like, and these are all it's like basically literally this is the same as all the things that we were looking at earlier, but this is just like the nice Gradio GUI. Yeah, it is pretty nice. If you want to run this and you don't want to run it on your GPU, you can run it out of this script, and I also link that in the links. This literally just like opens the thing. You see this Kohya, this thing right here, and then we'll give you the link to it, and you just connect to the link, and you should be all good to go. And then you can also, if you do it locally, you just download everything, and then you get it running here, and then you can see what's actually going on behind the scenes. Either way, you're gonna have, it's the same, but then it has all the same weights and everything. They also have some like advanced weights, and that's going to be that stuff we saw earlier. So this is like the gradient accumulation, and that you can change these things. Generally, you'll only change these things if your VRAM is really low and you're getting an out of kernel or an out of CUDA memory. If that's happening, then you'll change these things slightly. Like you might do an FP8 or you might do gradient checkpointing to make it so it can actually run everything. But I assume you guys won't have that problem because if I can run 8 gigs for VRAM, then you probably are going to be in a similar boat.
Use QLORA.
Or just use QLORA and be better, I guess. Yeah, that'd be better than me because I suck apparently. And then like if you're doing the low-con, you can do the convolutions. They just let you update. Basically, do whatever you want. You can change anything you want on the sampling. Yeah, so you can mess with it a lot, and it's pretty nice. And then the dataset preparation. So if you're doing it on here, it's the same thing as like I showed you earlier, where you can give it the instance and you can tell it what the class is, and then what the training stuff is. So it's the same stuff we saw earlier. The only thing that's different here, and that I will note, is that if you're doing it locally, you need to have like a very specific file structure for this to work, or it will literally, the script will just straight up crash if you don't do this. So you see how I'm doing this destination training directory, I'm doing this Kohya training, right? If you do this and then you'll click copy info to folders tab, and when you go to the folders tab, it will give you these things. So you see this image, it will give you this model and this log, right? And then if you have regularization images, it will do like /reg. They won't make the directories for you. So it will literally just like, there will be nothing in here, and it will be pointing at things that don't exist. So when you run the script, it will just instantaneously die on you, and they won't tell you why it died. So when you do this, or if you do this and you make like a Kohya training, like, or whatever you call it, just make sure to add the image, log, model, and reg, just like corresponding to these folders they have on here. Like they just need to be the same names, or it will just die on you, which is really annoying. And then the output is just like the name of the. So if I named it Owl the dog, it will just change the LoRa name. And then you can choose your where you're training from, or what model you're using as the pre-trained model. And then I just use the realistic vision, and that's basically the whole like thing. This is all stuff we've seen before. So you like if you can port all of it over from the Colab to here. There's a little bit more you can do here, as you can probably see. You can like you can extract LoRa's from models. There's a ton of stuff you can do in this thing, and it's really, really cool. And they also have textual inversions. You can see the textual inversion training is like, it looks very similar. There's just a couple things you need to change, like the well, I don't think you even have to change anything here. It's mainly just the data set is going to look a little bit different because you need the captions. And then this is just for fine tuning. So basically, all those 4 things that I mentioned earlier, this GitHub repo, like this Gradio, will just combines all 4 of those like big scripts that I think that I said were like good, and it just puts them all into one place. So it's really, really cool. I really like it. And then you can do flip captioning. It just has everything. It really just has everything that we talked about. Yeah. So I think that should be good for these 2. Did you guys have any questions about those 2 that we just looked at? So before we break, there's one more thing I want to show you guys, and that's going to be OneTrainer. Let me really quickly just start. So this is the one that people apparently really like and uses way less RAM. It should get started pretty quickly, and we'll see in a second. But there's like really little documentation on it. I like continuously keep trying to like look for documentation, but the only documentation they have is like straight up on their Discord. So you can join their Discord and like ask questions, and I'll get started in 1 second.
On the Discord.
Yeah, I could show you.
I don't think I've ever seen that before.
Oh, there you go. So yeah, this is what it looks like. It looks pretty terrible, I know, right?
What in the 2004 is this?
Apparently, like people have made it really nice. I just don't know like how. I think people like what's crazy is I think people mod OneTrainer. Like they mod it, so they'll like make it dark mode on their own.
Yeah, I would do that if I was using it.
Well, yeah, but like people people really like this.
You know that SpongeBob meme where it's like my eyes.
Yeah, this is how
I feel.
Yeah. They picked the worst font.
My eyes are actually.
So people like change the fonts, and then people like
It seems like they like went out of their way.
The font, the color scheme is also trash. Like everything's trash.
Like, I think the buttons are supposed to be circular. I think they're supposed to be like oval. But
yeah. So people like mod it to be
So
circle.
pixelated.
I don't like I. Apparently, it uses like. It looks like it uses way less VRAM, and probably
They wanted you to like.
They're like, this uses less VRAM. Take notes. Look how little.
Look how little. Look how optimized it is.
We made our GUI trash because it will save VRAM for you.
You're welcome.
So people apparently really like this. I've been seeing a lot of like hoopla about it.
This is some like play framework.
Yeah.
Work right here.
I bet it was
Play framework. So yeah, you can generate captions and generate masks for your captions and stuff.
You'd have to pay me to use this.
Yeah. So I haven't tried it. I just downloaded it just to show you guys it exists and to mention it. I'll probably try it and get back to you guys and tell you if it's actually any good. But for now, like personally, Kohya SS has been really good to me, and I really like using it. So if you're gonna train Allura, I would probably just use Kohya SS and then just use the base stuff, like the most common stuff. Like I know that's so normie of me to say use the basic stuff, but it's okay because it's the best. So cry about it. I don't know. And yeah, so I think that's everything I wanted to show. You guys have any questions for me after meeting or at all? Like if you're training Allura or whatever, feel free to ask in the chat. And yeah, all good.
So you don't have any examples, but you have like examples of like what could have been.
Oh, I do have an example. I should probably run my example. Yeah, that's such a good idea. Here, let me swap. It's gonna be trash because I trained it for one epic. I trained it because I was gonna train it on Hugging Face and train it for a while. I had like 3 hours to train it, and then and then it just crashed. I was like, there's no way. It was actually the most unfortunate timing like ever. It was such bad timing. It was so bad. And also sorry because this thing my PC's like slow, so it will take because I put it on the D drive. So
Windows user.
Yeah, it's my fault for putting on the
So
slide.
I will always make fun of you guys for using Windows.
No, I convert my desktop to Linux.
Yeah, use Linux. That's
It takes 0.1 seconds to change.
I believe it.
It does.
Yeah.
To do stable
There we
cells,
go.
like 0.5.
Let's go. So let's see how bad this is. I'm gonna use Euler A, and we're gonna do 35 sampling steps. If you guys are wondering like why I choose these specific settings, you can ask.
Practice.
Vibes in practice, yeah. I'm not using any easy way right now. There's no way.
No, you got to give the computer science explanation. It's a heuristic.
Oh, yeah.
That's poker. We don't know what we're doing.
All right. What did I get? Okay. Come on. I believe in you. Do we think he's going to get it this time?
So it's a guess? No. It's a heuristic.
Basically just means like, well, the conditions are that will require it. It just had to be that way. Why did you take that building?
There you go. That's what it generated. So, not very good. I literally just gave it my Laura.
Wait, why don't you give it the Laura and then like
a ton of other stuff is what people do.
No, why don't you give it your Laura and then one of the text prompts you have?
What's the desired output?
The desired output is that it looks like the dog.
But what if you say like
It's a cat.
Yeah, like you can. So I know that people use Prompt Hero for this. Stuffed toy, stuffed animal, stuffed dog. Yeah, I don't know.
Cat.
Ugly, disgusting. Cure. Actually, I forgot I put Fluffy in here. Yes, that's so good. Disgusting, horrible, horrific, horrified. Let's do horrified. Horrific. Terrible. Oh no good. Absolutely insidious.
Wow.
Atrocious. Cats. Abysmal. Yes, abysmal. Hopefully I spelled that right. Okay, we try again. Let's see how long it takes for my. Oh, look at that. Oh, that's pretty horrible. It looks like.
What am I looking at? What is that, bro?
You should put the
It's kind of cursed.
the text that you trained it on. Try that.
Oh, I can try
Because
that.
that would be
I just didn't train it for long enough. It's really the problem here, but I'll try
How
it.
many
that's
epochs
gonna
do
be
you
a
need to
no
train it?
for the model.
Huh?
How many epochs do you need to train it?
Generally, you'll train it with like you'll make the set number of repeats 40, and then you'll add you can add that regularization images you want, and then you'll generally do like 12 epics or 10 epics.
Oh.
So it will be like it'll be 800 per epic, and then 10 times, so it'll be 8,000.
Right.
And I did 200. So for the amount of time I gave it, it's doing pretty well. Okay, I think it's doing a pretty good job. You can see it also. You can see like it has a lot of the thing from it has remnants of the images I gave it because there was that wall like I forgot what it's called, like the popcorn wall, and it like generated the popcorn wall, and it didn't really mean to do it. But you can see there's like remnants, and that's why you give different backgrounds and stuff because it will like correspond or correlate those things and be like, oh, this dog is correlated to the ugly popcorn wall.
use case is limited to the training data you supply. Right? This is only going to be good for like that dog.
Yeah, it's gonna be good. Only good for that dog.
I mean, if you have enough data on that dog, would it be better to just build a whole model based on that dog?
Well, that's the issue is that you can't really build a whole model on it because stable diffusion is going to be like impossible to fine tune or train.
Well, you can basically like this model is general knowledge, and if you train it on your dog, you can say, oh, I want my dog to be in some place, and if you just train it on pictures of your dog, then it'll only generate like a few. It'll be terrible because it has no general knowledge of things. But if you do it this way, it's even better.
So the model you know is not realistic. Switching that will have a bit more drastic effect.
I think one way I like to think about like fine tuning is like when you train like on a huge data set, right? So like some kind of web scrape of the internet, you get like a pretty wide distribution. But then when you fine tune, you narrow that distribution a lot. So if you go outside of that, these models, they are not good. They can interpolate well, but if you ask them to do something out of distribution, it's not going to go well. So when you fine tune, that's kind of one of the flaws of fine tuning. Honestly, that's not as bad as the last one. It's better.
Oh, sure.
It's marginally
That's
better.
not bad.
It's not bad. I just need to train it longer. Is really the issue.
But that's okay.
You know, Hugging Face was up right now. I would. It's actually so annoying. Like I don't know why this had to happen today. It's very unfortunate. It doesn't do a bad job though, even with one epic. Like you can see, it's still doing like pretty okay. Even with like just the Laura.
To take it down just for you, just to ruin your day.
What if I weight the Laura like for 5.0? This is gonna be here. Let me make the sampler pointer or just exponential, so it doesn't explode. Hopefully, it might still just explode and look horrible. prepare your eyeballs for whatever this looks like. If it will ever train or ever go.
Oh, it's going.
Oh, no.
That doesn't look that bad.
Oh god, that's terrible.
That's heinous.
It doesn't look horrible. I thought it would be way worse than that. I went at 5. It would have been really bad. Yeah, I guess. So it's interesting how it like gets that like it gets like the fluff from the like the stuffed it gets like the stuffed animal fluff on the head for some like because of the Laura.
Show a picture again that you pulled up. It's confusing the nose.
Yeah, it absolutely. Here, let me get it again. No Christmas hat either. Can you get an F in the chat? Yeah. It didn't do that very well. And there's way too much fluff too. Oh well. Yeah, that's why I have to train longer. It's very sad for me. But alright, yeah, that's all. Did you guys want to see anything else? Or any other things? I think we're good. Alright. Yeah, sorry I went like 30 minutes over time too, so I also got here late. I've been running behind schedule like all day. It's been so annoying.